Today, I have the privilege of welcoming Bel Lazar to the C-Suite Spotlight. Bel has a wealth of insights about the semiconductor industry, having over 30 years of business leadership experience at prominent companies like Microsemi and International Rectifier. He's led $100 million business units focused on the aerospace and defense sectors and has led 17 M&A transactions, which showcases his business acumen and strategic ability to spot market opportunities. Bel worked his way up to the C-suite and became CEO of API Technologies. He also served as CEO of Freebird Semiconductor before reconnecting with Alex Lidow, who he knew from their time at IR. Bel joined EPC in 2015, and then in 2020, the EPC team decided to spin out EPC Space in order to focus on bringing radiation-hardened GaN power devices to the aerospace and defense markets. I know we're all excited to learn more about your impressive career and EPC Space, so let's get into it. Welcome.
Thank you, Jason. Appreciate your time and looking forward to this interview.
Absolutely. And Bel, I like starting with this question because it raises such interesting personal stories. What initially got you interested in engineering to begin with?
So, in elementary school, junior, and high school, I was really good at math. I mean, just way ahead of my classmates. Good at math and also good in sciences. Not as much as math, but I was good in sciences and math. And so in college, I was fascinated by solving electrical circuit problems. So engineering was the right fit for me. I wasn't good in English literature or stuff that's not related to math and sciences. So there you have it.
Great. What's the kind of the next step was continuing your academic kind of progression. And so you later earned a master's, continuing that kind of math side of things, a master's in computer engineering with a focus on artificial intelligence. AI seems ubiquitous now, but it wasn't so much back then. So was this a calculated decision?
No, actually, it was not. And that is the problem because I went to grad school and I said, you know what, I like computer hardware. And at USC, University of Southern California, they had an advanced computer lab for artificial intelligence at that time. And I was intrigued by it. I thought, maybe, I could find any job I want. And so I enrolled in this program. And to my surprise, and it shouldn't be surprised now, there was no jobs in artificial intelligence. When I would tell people I have artificial intelligence, computer vision, they say, what? So it wasn't really calculated. I just liked it, and I thought there would be a future for it, but it was way too early. And I ended up working. Luckily, I ended up working in a semiconductor company, but it wasn't really calculated. Except more was much more than I liked the topic, as opposed to I'll find a good career at AI. Although I wish it's now, but
Right, exactly. Very
yeah.
cool. Very cool. Okay. And in addition to that background and your scientific degrees, you also earned a Juris Doctor, which is really the only educational background we have in common. How has that served you in your semiconductor career?
So in the early 90s, after like several years at in semiconductor, I decided, and I had about 300 people working for me in my organization. And so I said, maybe I should go and get an MBA. And I looked at the various MBA programs. I looked at the PhD, and all PhD good schools were like during daytime. I couldn't afford to quit my job. So I looked at the MBA and looked at the MBA, and I had like 300 people working for me. And I was like into maybe sixth or seventh year in management. And then I said, maybe I'm not going to learn that much from an MBA. And I was always fascinated by the American jurisprudence. So I decided to go to law school instead of an MBA. And I did it at night. And it was fun. I was looking around my colleagues. They were struggling because they had to pass the bar while I didn't have to pass the bar or take the bar to pass the bar. So law school was fun for me. Yeah.
Yeah, and that's usually a 50-50 depending on who you're talking to, whether they really
Yeah.
enjoyed law school or whether they didn't. So that's a very, very,
Yeah.
very cool kind of origin story there.
Yeah.
Shifting gears to talk about your industry experience, we often see great tech advancements emerge from the aerospace and defense sectors. That's been a constant theme throughout the decades. And you've led A&D business units for some of the largest semi companies. In your view, which power semiconductor innovations have made the greatest societal impact over the years?
I think the switch from bipolar to a MOSFET was a major switch that allowed actually a lot more efficient electronics, which everything we, as you know, our lives depend on it in terms of how we spend our energy, and so it's a huge shift. And now here comes the wideband gap. Now in the 90s and the early 2000, it was very expensive to produce. But now, if you look at the gallium nitride, it could be produced at a lower cost than a MOSFET. And so it's just a matter of time where users will switch to gallium nitride or any other band gap material, depending on your application. So GaN will have a huge impact on our society overall.
Great. Yeah. And this next question is actually ends up being more of a tag slash follow up. But I mean, you've been at the forefront of technological trends in power semiconductors for decades. What are some of the biggest changes you currently see happening in this sector?
You'll see as with the AI, right? I mean, the amount of the need for computing power is tremendous, and all these servers that require crunching a lot of these numbers and processes require is going to use a lot of heat, and then gallium nitride is perfect material for that, so that we can actually allow our computers to crunch numbers faster, more efficient, and obviously with less generation of heat. And so I see a major trend going to gallium nitride now with silicon. There'll always be some use of silicon, but in most of the advanced applications, the switch is happening now to gallium nitride, and so we're witnessing during these years.
No, absolutely. Yep. Big theme out there with heat and GaN, that's for sure. Shifting gears to talk about EPC Space. For those of us who are unfamiliar with the company, can you tell us why it was founded and a bit about who is involved?
Sure. So the company was founded in June of 2020. The reason we founded it was we leveraged some of the technology advancement at EPC. I myself, I'm an EPC employee, so I'm the CEO of EPC and also CEO of EPC Space. We leverage some of that technology and make the product rad-hard. And I'm familiar with the rad-hard business, and so is the CEO of EPC Corp, Alex Lidow. And so we thought it was a great opportunity to offer to users of the power semiconductors a device that works good in power applications for space applications. And so we launched the company in 2020. We had consolidated the assets of a company called Freebird, which was using EPC gallium nitride devices anyway, but we've went into a newer generation of rad-hard devices, and so we saw a need to produce these rad-hard devices for the space market, and we launched the company, which has been extremely successful. And since June 2020, we're about 30 of us here at EPC Space.
Okay, great. Yeah, and if you're able to get specific, can you share any technological breakthroughs that you guys have achieved related to the use of GaN at EPC Space?
Sure. We were able to get the devices really small relative to silicon, much smaller, and we're able to, we had like, if you look at there's two elements in radiation. One is called TID and one called single event. With gallium nitride that we produce, TID is not an issue because there's no oxide layer, and so it goes into much higher multiples of the required. Let's say you need 1 megarad, we can get to like 40 megarad, so it automatically, it can meet all the TID requirements. So we were able to get that, and in addition, we were able to produce devices that meet what we call 85 LET at single event, which is on every part that we produce. And so we've taken out the radiation headache from our users. And so those were the major breakthroughs, in addition to like reliable size, cost, and the radiation effects. The radiation is not an issue for the gallium nitride devices that we produce.
Gotcha. And that also kind of bleeds into, looking at this from the customer perspective. I mean, some of the challenges that your customers face in achieving their goals, and kind of how EPC Spaces solutions are helping them solve those challenges. Maybe an example or two.
Sure. So we could continue the discussion on radiation. So we did talk about. So there are, I would consider, about five elements that actually help the user with these gallium nitride. And one of the most important is radiation. So now we have taken out. We have achieved a point that the user of our devices the users do not have to think about the radiation effect. So we got good TID, good single event. So that's one. The second with our devices is that we produce, our devices are highly efficient. And so by doing, we get what's called low RDS(on) and low switching losses. And if you compare it to our competitors, which is my old company, we are in tens of times more efficient. So that's the second point, is the efficiency. A third point is the integration. With the gallium nitride device, it's a lot easier to integrate, and the future is in the integration. You develop what's called integrated circuits, ICs, and so it's a lot easier to develop ICs for power application in GaN as opposed to a silicon. And a fourth topic or issue is reliability and heritage. We've performed tens of thousands of actual reliability testing, tens of thousands of hours of actual reliability testing, and we have significant heritage now. We have more than 200,000 rad-hard gallium nitride flying at various orbits, LEO, MEO, and GEO. So we've got reliability and heritage. A fifth, which could be important to some users, is cost and availability. Our rad-hard products are significantly lower cost than our silicon, sometimes more than 50% lower cost than the silicon rad-hard MOSFET. At the same time, our lead times, we have a very efficient supply chain. Our lead times are less than 13 weeks. And with a lot of the products available on the shelf, either at DigiKey or Avnet, or available at EPC Space. So those are the five elements that help users.
No, that's great, and kind of, pulling call it the viewfinder back a little bit and raising that. And you mentioned in one of your bullet points or elements there about the playoff between GaN versus silicon. I mean, there's an ongoing debate about whether silicon will continue to be the leading substrate, and the merits of GaN are obviously very well documented. Why do you think we haven't seen wider adoption of GaN yet? And what challenges do you think the industry needs to overcome to make this happen?
So, just like any other major technology, it takes time. And so we're making some progress, gaining some market share, but it will take time. And there will be most likely still some lingering usage of silicon. But eventually, the switch will happen, and as it's happening now. But it's going to take time because it's a new technology. Now, the adoption, it's not the GaN. Sometimes it's not a drop-in replacement. So you'll have to look at a driver associated with the GaN. You have to requalify your board. So there's a cost associated with replacing silicon, because the gallium nitride is not a drop-in replacement. And so it will take time, like any other new technology. Similar time it took to transition between bipolar and MOSFET, and we're seeing it now through GaN. But the world will change.
Very cool. Yeah, no, thanks for going through that. That's good perspective from actually somebody there on the ground, boots on the ground.
Yeah.
And if we're talking again, keeping that viewfinder kind of high level, the global market potential of GaN devices is in the billions. It's big, and the global market potential for rad-hard GaN devices not as big, but it's still in the hundreds of millions. But it's not necessarily a drop in the water, so to speak. But some analysts may critique the decision to do a startup focused on this sector. What would you say to them?
I would actually kind of agree with them on a standalone, because you would require to invest a significant capital in a wafer fab or a foundry that can produce this. but we're not. EPC Space is not doing it alone because EPC Corp produces millions of units, per month, or So what we're doing is we're leveraging that manufacturing line to make a vertical that specializes in rad-hard. So we're able to leverage the IP, the assets, the R&D at EPC, so we could do this startup that's focused on GaN. So we're more of a vertical that's leveraging an existing production line through the parent company, APC. So it makes sense, but you're right, and people would be correct if they say, "Why would you do a startup for $150 million market?" It doesn't make sense, but it does make sense in terms of how we're doing it. We're leveraging an existing production line.
No, yeah, the synergistic model. I mean, it has been done before, and it has proven out successful in other examples. So makes a lot of sense. What is the most exciting feedback you have received from the market thus far? Or it could be, a similar question is, what's your team's proudest deployment of your technology to date?
So there's a large number of satellite in a large constellation that uses EPC Space devices. When I read the news about that constellation, I'm very proud. So it's always good to see your products working well in space. That's one. And I have to tell you, Jason, I've the last couple of months I visited 20 customers. And every customer I visited, they told me that most of their new designs are including rad-hard GaN, and so the switch to GaN, rad-hard GaN, is inevitable. It will replace silicon. I mean, it's just a matter of time. So that's the most exciting thing. Is you go to a customer and say, "We love your devices, and all of our new designs have your devices in it," which means the future is bright. We also see when we see our heritage with satellites flying using our devices, that's also very exciting.
Yep. No, I'm sure most people, if they wanted to do some research, can figure out where your products are in. Assuming that EPC is successful, what impact do you believe the company will have on humanity as a whole?
I mean, in general, our products are efficient, which translates to efficient energy and efficient energy utilization. It's just much better for everybody and for the environment. So we live in a world where you require more computing powers, and more computing power using gallium nitride makes a lot more sense from an efficiency standpoint, and that helps the environment and it helps us all.
Yeah, and that kind of plays itself into the support, that the external support that companies like EPC can get, not only from the value add to humanity as a whole, but being recognized by other entities. And so we've kind of had this trend. The U.S. Chips and Science Act has been
Yeah.
advantageous to multiple semiconductor companies, looking to advance their technology through research and development grants. Has EPC pursued any of these funds? And if so, why? If so, why? If not, why not?
Yeah, actually, we have. We have not been successful. Would love to get some EPC Space. Would love to get some funding from CHIPS Act, and CHIPS Act unfortunately has been beneficial to a larger companies. We just have not been able to get funding. But if you can help us, or somebody can help us get some funding through CHIPS Act, we would love to talk and would love to get some funding so we can do more advanced stuff.
Well, yeah, CHIPS Act funding discussions and strategies and piercing that veil is a whole other potential discussion that I think a lot of executives have very interesting opinions on. So yeah, no, but it's good to see the support out there, and hopefully it does trickle down to companies like EPC sooner than later. There is yet again, and it's still on the mindset of growth. CHIPS Act is financial growth, but talent growth. You're based in greater Boston area, which has no shortage of bright minds, but there's also a ton of competition for top talent. As a smaller company, what strategies has EPC Space specifically employed to attract the right people?
So it's a good question, and it is challenging to find talent. But what attracts our employees is that we've given our employees flexible schedule, unlimited PTO, support in case of emergencies or family needs. And we have found a lot of talent, and actually most of our new hires are I would say probably like 26 or under, a lot of them out of school. And so we're finding good talent, and we're lucky to be in this Boston area, very close to the technology hub. And we're able to recruit because we set up a very good environment for employees, and it's also they're intrigued with the technology breakthroughs that we have here at EPC Space.
Okay, and kind of taking a cue from that last statement you just made. So if you're talking to an engineer or an engineering leader who is currently employed, doesn't need a job, but they're curious about EPC Space and what they're doing, what would you say to convince them to consider joining? I mean, outside of the obvious, culture you're developing there from a good place to work, but from an engineering perspective, what would you say?
Yeah, I mean, most engineers that I've talked to and I've recruited, they're intrigued by the fact that these products end up in space. The space business has become, if you will, sexy. A lot of newly graduates, they want to work in an environment that is related to space. And so we show them some of the semiconductor breakthroughs that we have, and we show them where our devices end up. And the young engineers are excited about this. We've hired people from top schools, top engineering schools in the Boston area and outside Boston area. So we have had no major issues really. And uh, as a matter of fact, we have for each position we had multiple candidates to choose from.
That's a great position to be in. Well,
Yeah.
good, good. What are, from a culture standpoint, what are two things about the company's culture that you are most proud of as the CEO, that outsiders may be surprised to learn?
Maybe not a surprise to many people, but the creative work environment that we facilitate. We don't micromanage anyone, and we allow creativity. And once you give an engineer a lot of space, creativity is unrestrained and unlimited. So I'm most proud of our creative work environment.
Bel, how can someone get in touch with EPC if they want to discuss partnering with the company, purchasing product, or even potentially joining the organization?
So we're extremely active on social media, LinkedIn, our website. We actually have a notification, immediate notification. We use tools that notify the senior management of anybody's hitting the contact button on our website. Same thing with LinkedIn. So the best approach would be either through our website by contacting us on the website. We respond to such inquiries within, I would say, probably hours. LinkedIn and our website are the best way to approach us.
Great, great. Now that's very, very helpful to know and for the audience to know. And Bel, I want to thank you for taking the time out of your busy schedule and day to speak with us and meet with us on the SBT C-Suite Spotlight. It's been great learning, getting to know you better, your story, and EPC Space's story. So we're excited for your guys' success, your growth, and should be a really, really fun story to follow as time goes on.
Thank you, Jason. Thanks to SBT. This has been it's been my privilege to talk to you, and I want to thank you and thank you very much for what you're doing in terms of posting on LinkedIn. We appreciate it and appreciate your time, and thanks a lot.